Hello and welcome to this Megger studio, and we're going to handle topic smart grid and digital substation. I am Niclas Wetterstrand, and with me today I have Mr. Andrea Bonetti.
Thank you, Niclas. Thank you very much for inviting me into this experiment. I see also a very nice backdrop of Megger with the smart grid behind it.
Yeah, that's new for this studio, of course. We need to do a lot of new things, but yeah, it will be interesting. This is a pilot episode, and we're trying to run, or we will do more of them, but we rely on your questions. We have actually, prior to this episode, got questions through LinkedIn, and we will answer a few during this session. So I hope you manage.
I hope also I will manage, and I will do my best to answer as clear as possible.
Perfect. Let's begin.
All right.
First question I have is, how long have Megger been involved with the IEC 61850 and digital substation?
I think that Megger has been involved in principle from 2007. So early beginning of IEC 61850 edition 1, definitely. Relay protection, first relay protection started in 2003, 2004. So then the need of testing in 2007, we came out with the first prototype, first product already in the beginning of 2009. Both hardware and software with new concepts, patented concepts, or by the way, comparison between data on the network and data on a file, engineering file, SCL file, diode, goose diode to separate the computer from the substation.
Yeah.
Things that are now getting popular by also other vendors, but we started that already.
Interesting. So we've been involved a long time. Something I hear a lot about is KEMA certificates. Can you explain a little bit about that and what it relates to Megger products?
It's a generic question, I think, not only Megger products, but it's the KEMA certificate, KEMA conformity or certificate is from a third-party laboratory, is a certificate that shows the minimum requirement for interoperability at the communication level, but now we have other levels of also SCL file import levels. But anyway, the minimum effort to show interoperability according to the IEC 61850 standard. And it's, let's say, if you take a third-party laboratory, independent laboratory, like KEMA or DNV today, it's called the Level A certificate, and this is important to understand. And then we have the Level B certificate where, for example, the vendor itself can have a laboratory for performing the test.
Self-certification.
Self-certification, and at this point you do something which is smart. You do a new firmware revision, you go a Level A certificate, and then small changes, you can do a Level B certificate. But Level B is not independent from an independent lab, I would say.
Okay. Something we hear also a lot about within IEC 61850 is goose messages, sample values, etc. And some refer to this like a series of communication protocols. Can you explain a little bit about this?
Yeah, the fact is that you need the protocols to communicate with the devices. So the focus in the beginning has been on protocols. But IEC 61850 also from the real beginning has been much more than a protocol, and that's why it is more powerful than other standards, protocol standards, because it describes the protocols, standardized protocols for goose, sample values, MMS, for reporting, vertical communication, but then it describes also how to describe how to map the data model of the substation, the device, the substation, and also the communication into a standardized format, which is SCL language and the SCL files. And this is completely new. Nobody had anything like this before. And also it describes a way of working, a process for engineering process to do the substation, the electrical system in 61850. So it's much, much more than a protocol, absolutely.
Yeah. So it sounds like more than a protocol, not only communication and data protocol. You mentioned there SCL files, and I heard a lot about different files in this area, so SCL, SCD, etc. Can you explain a bit about this?
Yeah, the big news about IC 61850 is actually the fact that we have a standardized description language to describe the data model. So I have a language to describe distance protection, the distance protection signals, overcurrent protection, but also PLC, control loops. It's not only relay protection standard, absolutely not. Then this data model, standardized data model, is described in SCL language. And this SCL language is at the end found into SCL file, which is an XML file written in SCL language. Depending on the information that you have on this file in SCL language, you have different names of the files. So one SCL file that describes the capability of the relay, of the ID, is called the ICD, ID capability description. But you can say, give me the SCL file with describing the capability of this ID. We understand. If you just say, give me the SCL file, I will ask you, what do you want to have in the SCL file? And then I find, for example, an SCL file that describes a complete substation is called SCD, Substation Configuration Description, or System Configuration Description, depends.
So if you compare the old substation description, if you put it that way, compared to how it's made nowadays, could you explain that part a bit?
So here the idea, if we consider the two parts of we can divide the world in two, or let's say the two condition situations, analog substation, and we take the other part where we have the digital substation. Considering the analog substation, we know well how we describe this substation. We describe the substation with so-called as-built drawings. These are a lot of drawings in a lot of binders, and they describe all the connections between relays, binary input, binary output, all the analog connection between the current voltage transformer to the relays, all the connection to the circuit breaker. There are thousands of pages of drawings, of course. And as I said, the as-built drawing is a very important part of the description of the analog substation, and everybody agrees that part of the delivery is the as-built drawings of the substation. If we go back to the digital substation instead, of course, we still have the as-built drawings. There are less. We still have some analog connections, and the more and more we digitalize the situation, the substation, less drawings will be needed. But today they still exist. But we still have also, we have something new called the SCD file, System Configuration Description, or Substation Configuration Description, which describes all the devices that are in the substation, numerical devices, of course, everything that they can send to each other, goose messages that relay send to another relay, MMS reports the relays send to the station SCADA, for example. And this is very important part of the description of the substation. And we need to learn that we also want to have the as-built SCD file as part of the delivery of the substation, which is very important also for, not only for documentation, but for future design, for future improvements, maybe some upgrades in the substation or some new base.
It's obviously much more than a data protocol, as you have talked to. What are the benefits by having it this way instead of a simple data communication protocol?
There are absolutely many benefits. The first benefit that I have to say is that we have a description on how to do the engineering. Standardized description on how to do engineering. We never had a description on how to engineer a substation. So now we have a flow that you can follow. You can say, okay, I know that if I do that way, I will do it. Then we have different methods. But this is something completely new. Everybody wanted to have this flow, and it has not been standardized. The second one is that I have a standardized way to describe, to engineer, to design, to specify, and to engineer and describe what I've done into this SCL file. So when we have the engineering SCL file or the as-built engineering file, SCL files, we can actually, we know that this file, for example, describes the communication of the substation. And in the communication of the substation, there are goose messages. So the SCD file, as-built SCD file, must describe all the goose messages that are sent and received in the substation. Otherwise, it's not describing the substation.
Yeah.
It will describe many other things, but let's take this part.
Yeah.
Now, I have a method to read all the goose messages that are really available into the network, in the Ethernet switches, in the fiber optics. I can sniff the communication and detect all the the goose messages there. Which are described, as I told you, in the SCD file.
Yeah.
If I could compare, I can verify that my substation is working according to the design. Or I can compare, I can see that the SCD file describes the substation. It depends how you see it.
Yeah. Yeah.
And this is something that opens for a lot of things that we have also produced some software tools to use this.
Yeah, IEC 61850 and goose messages, in the beginning at least, was very much tied into relay testing. But obviously it's not just relay and connected to relay testing. So where do this go?
Yeah, of course, the relay contact that goes to the circuit breaker now is supposed to be, and it is, a goose message sent by the relay that has been received by a 61850 circuit breaker or by a device that can understand it and trip the breaker. And that's why the focus was on the goose messages, because it's a real-time message that carries protection signals, trip, stop, blocking, whatever. But if we could run the substation without the goose messages for the trip, we'd go still by contacts, for example, and use goose messages for something that is less real-time. Still, we have the SCD file that describes the substation. Still, we want to do maintenance routines and see, is my substation working like yesterday? Is my substation still conformant to the description of the SCD master file? So I take the goose messages flying the substation, I compare with the SCD file, goose message in the SCD. Every day I can do this.
Yeah, yeah.
And if I find a difference, I tell you, well, I don't know why, but there is a problem. The substation doesn't behave anymore according to what is written in the SCD file. Maintenance routine, flag, automatic maintenance routine, flag, let's go and open the box and find the problem.
Interesting. So we go there and we sniff the goose messages or sniff the network, what messages there. We have the description of what should be there, we compare and so on. How often is this discovered? Is it daily or is it never?
No, if we have not implemented this automatically, so that I cannot answer you if we do this every hour or every day automatically. Our tools are done, can do that, but they do it manually. So you have to personally go there and do the sniff, read the SCD file, compare, etc. If we could do it automatically, that would have implemented automatic maintenance routines, which still is under discussion. But we can do it is that this comparison we can do, for example, during factory acceptance test, where the customer wants to verify that the SCD file given by the system integrator really corresponds to the substation, or the opposite, that the substation really corresponds to the SCD file. Depends on what you say. Normally we validate the SCD file. because we know the substation works, we are testing it, so we want to validate the SCD file. And the comparison fails, you have some difference, you say, no, the SCD file has some differences.
Yeah.
And this, how many times we find differences, it's 100% of the times.
So that's how it is.
Yeah, but it's not because IC 6150 is bad. It's because the substation has been engineered in the wrong way. If they had followed the top-down engineering process, for example, you will go through this test without any problem, because you do the substation, you first SCD file, and blah, 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 you set all your relays according to what's written in the SCD file. If you do partial engineering, vendor A is using its own tool, vendor B is using his own tool, and they don't care about the other tools, and then at the end somebody will try to merge. That is where things will not work. But if you use one master tool and you do the top-down engineering, that will not be any problem. But it's not understood. I don't know how to make it understandable. It's not understood.
And that's where you get into interoperability problems, as you hear a lot about.
Yeah, but in fact, now, yeah, it's very correct. We have developed this comparison in the 2008. 2009 was the final product available, MGC, but in 2007, 2008 already we had this, because we had problems in the substations. We had interoperability problems in the substations. So I send a goose message, and that relay will see it. You don't receive it. Why one relay is receiving my message and you don't? Since you are using the SCL file to understand what you have to receive, you may interpret wrongly the SCL file, or sender may interpret wrongly the SCL file. And this comparison with what we see on the network, with what we see on the SCL file, if the comparison is not okay, there are differences, well, that goose message is suspicious. Maybe that goose message is carrying the problem. Now, I'm also interested to know why. Where are the differences? And our tool could do that.
Yeah, that sounds interesting and saving a lot of time, I can assume.
It's saving... Okay, frankly speaking, historically, the idea to do this was my idea, because I was tired to spend the nights and weekends in the substation. Because if you don't have the automatic tool that does this for you, you have to take a goose sniffer and read the goose message from the sniffer. And you will see the goose in a certain way. And then you take an XML file, which is SCL file, which describes the goose message in SCL. They are the same, but they are not really the same. And doing this comparison manually, it's painful.
Yeah, it's not.
Actually, you do a mistake all the time. So the concept was there, but we needed a tool that numerically can do this for you. And that was the history behind this algorithm, in fact, actually.
Makes sense. So you do this sniffing, you do the comparison, you get like 10 warnings. What happens next?
You can just write a report and say, it depends on your role. If I've been consultant many times as well, I can write a report and say, there are 10 differences, please find out why and fix them. Because the goal is not to have any difference. Or you can take another role and say, okay, I have to discover where the problem is and to fix it. So we can select the two messages that are different, and ask the tool to tell me all the differences that there are in these two messages. This is an extra step. You have to do it manually, but you have this possibility, so you can pinpoint it is a MAC address, it is a virtual LAN number, could be the application ID number, whatever. You know that is the difference, and you have to find out how to fix it. The problem could be in SCL, or the problem could be in the firmware of the relay that is sending the goose. So
some manual work and some intelligence still added to the process, of course.
When we do interoperability, in the investigation of interoperability, or when we open the box, you have to do manually. You have to be there physically with your test sets, with your head, with your competence. But the beauty of this is that we can give a warning, and this warning can be automatic. And so my substation will never have one warning. I test it every day, and every day is okay. Fine. Why should I test a substation if it is okay? But when there is automatic warning, then of course the doctor has to come in and use all the investigation possibilities. But we skip to test the substations that we know they are already working fine. This is the beauty of 6150.
Yeah. And you talk about this automatic, but it's not there yet. We have it manual. So is there any plans for going automatic, or?
Now we have, if we talk about Megger, we have, as I said, this concept is in place since the real beginning, since our 2008. And we follow the standard, edition 1, edition 2, whatever, and we implemented the new things in this comparison, fine. But this is a manual tool. We are manual test people. If we want to enter the world of automatic test procedures, maybe it's clear we have the competence to do that.
Yep.
It's just to do this automatically, but it has to be done. And we need a sponsor, we need somebody that is really interested in implementing this automatic maintenance procedures or automatic self-supervision procedures. It depends how you give the name. So at the moment we don't have it because we have no requests from the world to do it.
Okay. Yeah, but this is a good time then to request someone. If someone has the need to maybe contact you and go with the project,
What we do, we are writing papers. Now, many years we are writing papers on this subject. And sooner or later, somebody will say, okay, obviously we have to do it. But before you reach that point, you have to do sort of promotion.
Yeah, we'll see then. One question we have got through LinkedIn, which is interesting but swinging the topic a little bit, is how do IEC 61850 relate to smart grid?
Oh. In 2019, so 2 years ago, I was requested to write a speech or keynote on the relationship between IEC 61850 and smart grid. And this was maybe the most difficult speech note I had to prepare in my life, because the concepts are there, but when you have to land them in the correct place, it's not so easy. One thing is completely clear. IEC, International Electrical Committee, has standardized, says right now still, that core standard for smart grid, when they talk about smart grid, they list some not more than 10 core standards. Okay. Then they list many other standards, but the core standards are not more than 10. And IEC 61850 is one of these 10 core standards, which means that if you follow IEC, you may follow IEEE or something like that. If you follow IEC, and you do a smart grid, you must use 61850. There is no discussion. If you don't use 61850, you cannot talk. For me, you cannot talk about smart grid. This is an easy topic, which is very helpful because we have a standard to rely on.
Yeah.
But then, where I'm talking about SCD files, now that's, the standard also has evolved from edition 1 to edition 2. It was called, in edition 1, the scope of the standard was communication for substation automation. And in edition 2 years later, it became stand for communication in power system automation, something like that. So popularly we say the S, SCD, SCL, GOOS, generic object-oriented substation event, became system. The S became his system, from substation to system. And now system is a system of two substations that talk together. And one substation could be my solar panels at home, and the second substation could be the wind farm. And how this talk together, how describe this, we have actually all the tools to handle this system of substations, which is the smart grid. it sounds a little bit theoretical, but all the pieces are in place to handle smart grid in a consequent way. So I don't know if I answer, because it's not an easy answer, but 6150 is smart grid without 6150, for me, doesn't exist.
Yeah, as you said, you have made a presentation and a tutorial or keynote speech on this, so you can probably spend another hour talking about just that part. But for now, I think we have to conclude this first session. So thank you, Andrea. It's been really interesting to have you here, and we talked about many different subjects. And also I reach out to you that we got questions here to LinkedIn, through LinkedIn, and now we like more questions, so we can cover that in the next and coming sessions. So we didn't answer all either. We had more, but please come in with comments, and we will see what we can cover in next session. And hopefully I have you back, Andrea, and we get many inputs from the audience. So thank you so much.
Well, thank you, Niclas. I say also thank you to some of your questions are really coming from LinkedIn. I remember that we have posed a question a few weeks ago. And I also want to say thank you to all the people that have written something, because majority of the people don't comment anything. So I hope that we will get some other questions that it doesn't matter if you don't know how to answer, we don't answer, but we can work on those questions and try to help to improve the competence on 6150.
Yeah.
For substations and for smart grid,
exactly.
which is here.
Yeah, the smart grid is broad, so we have many topics to talk about in the future, I'm sure.
Thank you very much.
Thank you.